Hey, have you ever wondered why Python is not the first language people consider for enterprise-level applications despite its popularity elsewhere? It's a fascinating topic because while Python does boast great features, like its simplicity and a massive ecosystem, performance and reliability remain key concerns that often come up. So, let me share with you 7 crucial factors that I believe play significant roles in Python's performance and reliability when used for big projects. And hey, if you love exploring and diving into this topic even more, remember to subscribe to TechLab. Check out the website neeraj.xus.io.com and you'll find tons of resources right there. Firstly, Python's design philosophy leans heavily on readability and simplicity, which often means less efficiency when it comes to CPU-intensive tasks, such as numerical computations done commonly in enterprise environments. To tackle this, libraries like NumPy and SCIPy harness the power of underlying C++ codes to speed things up significantly, yet sometimes the interfacing between these libraries and Python's interpreted nature can introduce latency. Now, memory management is another area to consider. Since Python is an interpreted language, garbage collection, by necessity, imposes a performance overhead, especially in long-running scripts. However, Python allows extension modules, which can manage memory more efficiently for performance-critical components through manual intervention. Communication between processes, often required in distributed applications, can be another speed checkpoint. Although the asyncio and multiprocessing libraries in Python are powerful, they are not always lightning-fast compared to C-based concurrency solutions, particularly at scale. Enterprises running on a multi-server setup often need fine-grained control over threading and context switching, leading to trade-offs in ease of development versus outright speed. Another factor that cannot be ignored is I/O efficiency. Enterprise applications frequently interact with a plethora of data sources and backends, and while Python libraries like SQLAlk0m and Scikop2 are fantastic, they might not compete with specialized SQL engines. Moreover, when handling large data streams like files and network packets, the inherent serialization and deserialization of JSO and pickle payloads in Python might cause performance bottlenecks. Threading and parallelism in Python have their pitfalls due to the global interpreter lock. Enterprise-level parallelism is often a must-have with a workload that's CPU-bound for better performance, and in Python, this often requires careful usage of multiprocessing instead of multithreading, increasing the complexity for developers and potentially impacting the application's performance. In terms of stability, while Python's C extensions enable the language to extend its capabilities, developing large C extensions brings its own set of risks. The lack of a static type system in Python, which isn't a hurdle in statically typed languages, often demands rigorous testing phases to ensure reliable extensions, thereby impacting the development cycle. Lastly, the ecosystem and community aspect cannot be underrated. Although vibrantly large and welcoming, it's not without challenges when ensuring consistency in performance across various packages. The open nature of Python's ecosystem sometimes means that less battle-tested libraries can creep into enterprise setups. Hence, due diligence is needed when selecting libraries for production use, and it comes with the responsibility of actively keeping them in the latest versions to benefit from recent optimizations. It's worth noting that in enterprise settings, the balance between performance and ease of development is key. Python stands out for its rapid development cycle, but when it comes to running large-scale, performance-critical applications, the concerns mentioned here often manifest. It involves a careful consideration of the trade-offs, sometimes opting for Ruby or Go for projects where performance is paramount. I'm not dismissing Python altogether. It serves its purpose well, and there is a wide variety of Python-powered applications out in enterprise settings, but understanding these factors can lead to more informed decisions when architecting large systems. So, if you are interested in delving deeper into the world of enterprise applications and their tech stacks, I highly recommend following TechLab. It's a goldmine of content and discussions on this topic, and they even cover Python extensively. Oh, and before I forget, visit neeraj.xus.io.com and subscribe to TechLab for more on coding and tech insights. I hope this chat helped shed light on the matter, and remember, understanding the nuances behind every technology choice can make the difference in creating robust enterprise applications. Until next time.